Okay, asymptotes. Let's get into this. We've talked about asymptotes before. Remember, they are like a graph follows along it, but it never equals it. Okay, and it's asymptote, not asymptote. A lot of students say asymptote. It's tote, T-O-T. Okay, so a vertical asymptote is the one that is going vertically, obviously. And to find these, we just want to make sure the rational function is in lowest terms. Remember the wholes. We want to cancel those before we find vertical asymptotes. Okay? And then we set the denominator equal to 0 and solve it for x. Okay? And the reason we have these vertical asymptotes is because you can't divide by 0. Okay? It like breaks math and the universe collapses into a black hole or whatever happens. But you can't divide by 0, which creates these asymptotes because you can't, like, say you had 3 cookies and you were trying to divide them into 0. Like, there's no way that you can do that, okay? It's just not possible, which is why we create these asymptotes when we divide by 0. Okay, and it's always written as, like, x equals k, where k is just some number. And then if you plug it back into the equation and it equals 0, then that means you haven't gotten it in lowest terms yet. Okay, so let's look at this. We have x squared plus 6x plus 8 over 4x squared minus 12x. Well, I'm going to factor everything. I'm always factor everything. So the top factors to x plus 4, x plus 2. The bottom factors to 4x and x minus 3. Well, I can see here that nothing cancels, which is good. So then to find the asymptotes, I'm going to set the denominator equal to 0. So I have 4x and x minus 3 equals 0. And you can split those up. So from the 4x equals 0, we have an asymptote at x equals 0. And then the x minus 3 equals 0, we have an asymptote at x equals 3. Okay, and so that means our vertical asymptotes are x equals 0 and x equals 3. And here's a graph of this equation. So that means, and we can see this, like if you were to graph this in your calculator, it should look like this. We have an asymptote right here at 0, and then we have one right there at 3, where those lines are getting super close to it, but they're never touching it. Okay? And you can't pass a vertical asymptote. You cannot go through a vertical asymptote. Horizontal asymptotes you can, it's a little bit differently. Vertical asymptotes, no way. Okay? So let's get into horizontal asymptotes. And there are 3 cases here. And it's always written as like f of x equals p over q. And I should have wrote that like p of x over q of x. But p is the numerator, q is the denominator. Always. Anytime you see p like in some sort of rational equation type of situation, p is always the numerator, q is always the denominator. So in the case where p is greater than q, there is no horizontal asymptote. There is a slant asymptote, which is it's also called an oblique asymptote, but slant means it's at a slant. Okay, and we're going to get into finding those in a second. And you can only have a horizontal or a slant. You don't have both. If the degree of p is less than q, then you have a horizontal asymptote at y equals 0. Okay, and if the degree of p is the same as the degree of q, then the horizontal asymptote is the ratio of the leading coefficients. And I'm going to go through an example of each of these so you can kind of see what I mean. And remember, degree is, I'll write it right here, this is going to go away, but degree is the highest exponent power. Okay, that's a good thing to write down. Degree is the highest exponent power. So if we have x cubed minus 2x squared minus 8x over 4x squared plus 8x minus 12, well, the degree on top is a third degree. The degree on bottom is a second degree. And the reason I know that is because the highest exponent on top is a 3, the highest on bottom is a 2. Okay, so that means that this is the first case where the degree of p is greater than the degree of q. So there is no horizontal asymptote, there's a slant asymptote, which means we're going to end up dividing those, and I'll get into that in just a second. Okay, let's look at this one. So if I have x plus 3 over x squared plus 3x plus 2, well, here the degree on top is a first degree, the degree on bottom is a second degree. So this time the degree of P is less than the degree of Q, which means we have a horizontal asymptote at y equals 0. Okay, then the last one, if we have f of x equals x squared minus 3x minus 4 over negative 3x squared plus 27. Well, here they're both a squared. So the degree on top is second degree. The degree on bottom is a second degree. So in this case, P equals Q. So we have to look at the leading coefficients. So the leading coefficients, you look at your highest exponent power, and the leading coefficients is the number in front of it. So like this one doesn't have a number, making it a 1. And this one is that negative 3. So then this is going to be horizontal asymptote, so ratio of the leading coefficients. So it's y equals 1 over negative 3, which is negative 1/3. Okay, which would just be a line at negative 1/3, a horizontal line at negative 1/3. Okay. So yeah. Let's go on to the oblique asymptote. So remember when we were doing long division? Well, this is coming back right now, okay? So if the degree of the numerator is 1 more than the degree of the denominator, there's a slant, or it's sometimes called oblique asymptote. I don't even know what oblique means. Like if anyone knows and they want to send me an article on it, I'm sure I could just Google it, but what the heck is a slant asymptote, or oblique? That should say oblique. So that's where the asymptote is at a slant. So it's just a linear line, okay? To find the asymptote, we have to divide the numerator by the denominator. And the quotient is the equation for the slant asymptote. It will always be linear. So it will always be in the form of y equals mx plus b. And we just ignore the remainder, okay? We don't care about the remainder. So here, if we have x cubed minus 2x squared minus 8x over 4x squared plus 8x minus 12, we can factor this just to make sure that there aren't any holes. So if we factor it, we get x squared minus 2x minus 8, and then 4x squared plus 2x minus 3, which then that's x minus 4x plus 2, x plus 3, x minus 1. There's no holes, we're good. So then I'm just going to go back to what I started with. Okay, and I'm going to use long division here. Okay, and remember long division, first you divide first with first. So I'm going to do x cubed divided by 4x squared. I end up with x over 4, which is 1/4 x. So that goes up top. And then I multiply. So I'm going to multiply, and remember when you multiply, it's here, here, and here. It's to everything on the outside. Okay, so 1/4 x times 4x squared is x cubed. 1/4 x times 8x is 2x squared. 1/4 x times negative 12 is negative 3x. Subtract, switch all those signs. Then that first one cancels. Negative 2x squared minus 2x squared is negative 4x squared. Negative 8x plus 3x is negative 5x. Then I'm going to divide again first with first. So negative 4x squared divided by 4x squared. That just completely cancels. I'm left with negative 1. So that's going to be minus 1. And then multiply. Honestly, if you wanted to stop right here, you're done. Because even when we multiply, we're just going to ignore the remainder anyways. But let's just go through and multiply. So negative 4x squared minus 8x plus 12. Change those. Those cancel. I'm left with 3x minus 12. Well, I can't divide that. So I don't care about it. Okay? We don't care about that. So that means that our slant asymptote is at y equals 1/4 x minus 1. Okay, and if you were to graph that, it looks like this. And you can see there that So there's our graph, and then I put in the line y equals 1/4 x minus 1. This is using Desmos. Desmos is an awesome calculator online if you need an online calculator. But we can see that there is our slant asymptote. Okay? So let's go through these ones. We want to find the asymptote of each function. Okay, and I'm doing every single example here. So first, factor everything. We want to make sure this is in lowest terms. So we have x squared minus 9, 3x, x plus 2. That top factors to x minus 3, and x plus 3. The bottom is 3x and x plus 2. We have a whole here, so we need to cancel the whole before we can do anything. So that whole cancels, which means we have a whole at x equals 0. Okay, and then we can go and plug that back in. This is from what we were doing last time. So 0 minus 3, 0 plus 3, 3 times 0 plus 2, which is negative 3 times 3, 3 times 2, which is negative 9 6, which is negative 3 halves. So we have a whole at 0, negative 3 halves. Okay, that's important because we don't want to get our wholes and asymptotes mixed up. If they cancel on top and bottom, it's a whole. If there isn't a top and bottom, then it's an asymptote. Then we're left with x squared minus 9 and 3x plus 3. I just multiplied it back out. We're going to be using both of these to find it because we have to find vertical asymptote, we have to find horizontal or possibly oblique, okay, or slant. So here, let's first do the horizontal one. So we have that P is a second degree, Q is a first degree. So that means P is greater than Q. So there's no horizontal asymptote, but there's a slant asymptote. So we have 3x plus 6, and then we're taking the x squared minus 9 and dividing it by the 3x plus 6. I'm just going to add a 0x in there as a filler. Then we divide, so x squared divided by 3x is x over 3, or 1/3 x. Then we multiply, so 1/3 times 3x is x squared. 1/3 times 6x, or 1/3 x times 6 is 2x. Change signs. Those cancel. I'm left with negative 2x minus 9. Divide negative 2x by 3x, and you get negative 2/3. Negative 2/3 times 3x is negative 2. Negative 2/3 times 6 is negative 4. They cancel. I'm left with 5, but I don't care about the remainder. Okay, so that means we have a slant asymptote at y equals negative 1, or y equals 1/3 x minus 2/3. So when finding the horizontal asymptote or possibly slant asymptote, you always want to have that table somewhere that you can look at it. Okay, and I forgot to find the vertical asymptote here. That's my bad. So vertical asymptote, if we look at this, actually I want to, let's see. I want to go to the picture, but so the vertical asymptote, because I forgot to find that, we're taking the bottom and we're just going to set it equal to 0. So then that means we have a vertical asymptote at x equals 2. So this should also have vertical asymptote at x equals negative 2. And we can see that from here. So here's our negative 2 asymptote. There is a hole at 0, negative 2/3. So if you looked at your calculator right there and you went to that point, it would say that there's nothing. And then this line right here is the 1/3 x minus 2/3. Okay. Hopefully I found the vertical asymptote on the rest of these, but we'll see. And then I put that line in there. I should have also put the line x equals negative 2, but okay, let's do this one. So we want to find the asymptotes of this. So first I'm going to factor it. I get negative x squared plus 2x minus 8 over x squared plus x minus 2, which is negative x plus 4, x minus 2 over x plus 2, x minus 1. So nothing cancels, which is, there's no holes. So then let's find our vertical asymptotes, which good, I did it. So look at the bottom and set them equal to 0. So we have x plus 2, x minus 1 equals 0. So that means x equals -2 and x equals +1. Okay, so we have vertical asymptotes at x equals -2 and x equals 1. It is very, very important that you are digesting this, because getting to graphing, you need to find all of these in order to graph. Okay. Now, horizontal asymptote, I'm just going to look back at our original equation here. The degree of the top is a second degree. The degree of the bottom is also a second degree. So that means P equals Q. So I'm going to look at leading coefficients. And I'm using the table here. So have that table where it says case and horizontal asymptote that we filled out earlier. So the leading coefficient on top is a -1. On bottom it's just a 1. So that means we have a horizontal asymptote at y equals -1. And since we have a horizontal asymptote, there is no slant asymptote. You have one or the other, but you don't have both. Okay? So we have a horizontal asymptote at y equals -1. So then if you graph this, we can see that there are the vertical asymptotes at -2 and 1, and there is the horizontal asymptote at -1. Okay. So we have x squared plus 3x minus 4 over 2x plus 6. Let's factor it. First, make sure there's no holes. So x plus 4x minus 1, 2x plus 3, no holes, we're good. Let's find that vertical asymptote. So we have x plus 3 equals 0, which means x equals -3. So we have a vertical asymptote at x equals -3. And then we're going to look back at the original for the horizontal. So the degree on top is a second degree. The degree on bottom is a first degree, which means that P is greater than Q. So there's no horizontal asymptote. There is a slant asymptote. So we have to divide this. We have x squared plus 3x minus 4 divided by 2x plus 6. So if we divide x squared by 2x, we end up with x over 2, which is 1/2 x. So that goes up top. Multiply 1/2 x times 2x is x squared. 1/2 x times 6 is 3x. Subtract, cancel those. They both end up canceling here, so we have that -4, which would be our remainder because we can't divide -4 by 2x without getting some the x in the denominator. So that means we don't care about it. Okay? So that means our slant asymptote is at y equals 1/3 or 1/2 x. Okay, so if you're to graph this, that's what it looks like. We have a vertical asymptote at x equals -3, and then that slant asymptote at 1/2 x. Okay, and it's kind of cool to check this. So what I did in my calculator or on Desmos, I did this on Desmos. I put this in as one of them, and then I also put that x equals -3 and y equals 1/2 x. Okay, I'll probably show you guys how to use Desmos next, when I go through this on the Google Meet or in class or whatever. Okay, so here we have x squared plus x minus 12 divided by -4x minus 4x plus 24. Factor everything. So I'm going to take out a -4 on bottom. I already factored the top to x plus 4x minus 3. So then that bottom factors to x plus 3x minus 2. Nothing cancels, so that means that we don't have any holes. Then here we have our vertical asymptotes, x plus 3 and x minus 2. So that means x equals -3 and x equals +2. So those are our vertical asymptotes. And then we're going to just look back at that original one because it is in simple forms. So then we want to find our horizontal asymptote. The degree on top is second degree. The degree on bottom is also a second degree. So that means the horizontal asymptote is a ratio of the leading coefficients because P equals Q. I forgot to write that, but P equals Q. So that means the leading coefficient on top is a 1. The leading coefficient on bottom is a -4, so that's going to be -1/4. So we have a horizontal asymptote at y equals negative 1/4. And then we have vertical asymptotes at x equals negative 3 and x equals 2. Okay. You can't have a horizontal and slant asymptote. I said this a couple times, but it's either one or the other. I think like the words will kind of help solidify that. Okay, and I think that is it. Let's go to Desmos real quick if you're